Stick around. Everybody likes to talk and you know, about Rails and things not necessarily Rails. Have a beer and so forth. So, without further ado, let me introduce Chris and Terence.
Thanks, Ethan. Question. Let's put this in here. All right. All right, cool. All right, one last. Actually, I'm gonna pass this off midway through, anyways. So, welcome to Austin on Rails. It's great to be back. I was a former Austin on Rails member. Then I moved to San Francisco to work with Heroku. This is Terence. We're talking about deploying Rails 3.1 on Heroku Cedar tonight. So, git push Heroku master. No, we actually do have a talk planned. Quick about us, Terence.
So I work on the Ruby build back team, so that's just the end-to-end Ruby experience, and I work on Bundler, so if you have any problems, come talk to me about that, and the central contact information.
I'm Chris Continanza. I work on the Add-ons team. I call myself Patient Zero because the Add-ons app, among some of our other internal apps, is hosted on Heroku, so I get to eat a lot of our dog food, and I like the way it tastes. You can catch me on GitHub and Twitter as well. So for deploying Rails 3.1 on Heroku, we're going to talk about Cedar and the Unix process model, and I'm just going to head up that part of the talk. And then Rails 3.1 specifics is going to be Terence's domain because he's worked on that a lot and he knows a lot about how to make that work. So this is not a talk on how to use the asset pipeline or how to convert an app to use the asset pipeline. I think those are both very interesting talks and someone should give them, but that's not what we're doing right now. So what we are at Heroku, we have a platform as a service. So what that does is that lets us host your code and serve that to the world. You deploy your code to us with Git, and with us you scale processes, not servers. So our fundamental atom here is a process. You never have to think about how many processes can I fit on a given server. As you'll see, the Cedar platform especially has kind of gelled around this idea of the Unix process model and allowing you to scale processes individually and not worry about servers. And then for Rails 3.1, we're going to talk about getting the asset pipeline up and running. So the first question is, where is everyone at? Now we know we're in Austin, we're here, it's great to be back, but specifically I just want to see kind of a show of hands what Rails versions people are using, familiar with, kind of, so show of hands for Rails 2.3. Cool. Show of hands for Rails 3.0. Cool. And Rails 3.1. Cool. All right, great. So lots of different versions of Rails in the crowd. All right, so for the first half, Cedar and the process model. So when we think about the Unix process model, normally this is what I think about. A program, it can talk to standard in, standard out, standard error, 0, 1, and 2. These are all file descriptors, which is something that is kind of more fun back in the C days, but if you do file open 0 in Ruby, you'll actually get standard in. So a lot of those concepts come and apply to modern web development. But the idea of the process is just that it's an isolated task, it's running, and that there's standard ways to communicate with it. What we do at Heroku, and I borrow a lot of this from Adam Wiggins and his ideas about applying the Unix process model to web apps. So we take the Unix process model, and when we apply it to web apps, we wind up with this idea of a managed process, because you don't want a process that just runs and executes. You want a process that has uptime and availability. we allow you to describe these managed processes with a proc file, and we provide Foreman as a local gem to enable you to use your proc file to describe your processes, to run them, and then even export them to a different format if you decide not to host with Heroku. So the first thing there was a managed process, and what that is. So basically that means we're going to monitor it, we're going to restart it, and you're going to scale it. The idea behind the managed process is just that it's up all the time, and that things like it crashing, things like it grabbing too much memory, all of that stuff, things should be managed by the system and not yourself. You shouldn't even be getting an email, hey, my process went down. The system should be able to know that this happened, restart it, and your app should still continue. I mean, if there's bugs in it, then you might have a bug handling exception or some other add-on for that, but the idea is that, in general, your process should not be something that goes down. So, we have these notions of processes in Ruby, and this is something we're all familiar with seeing. You know, a web process, bundle exec, Rails server, a worker process. This is delayed job, and that's pretty much it. These are basically process types and then Unix commands that actually run them. It turns out we actually see a very similar thing kind of across the language barriers. So Python has the same thing going on. You'll have a web process and then maybe another worker process. I've worked on a closer application before. It actually has this similar kind of format. And so what the idea there is that with processes, and thinking in terms of processes, you'll have your web, your worker. This is an example of a clock process, which you would only want one of because it's sending out clock ticks. But the idea here is you don't want to scale, you don't want to think in terms of machines, in terms of units of work, you want to scale these processes. So this is an example of where you'd want to be, or what you're kind of thinking in terms of, is I've got 2 web processes, 4 workers, and a clock that's helping synchronize the workers. And the question is, how do we get there? So an easy way to get there is with the proc file, because that allows you to declare process types that look a lot like these keys. And lo and behold, the proc file looks a lot like what we kind of just saw when we were looking at what the different process types are. So here's an example proc file that's a little bit more involved. I'm doing a bad job of talking to the mic, but we'll have to, guys at the bar, enjoy the drinks too. So the web process, you know, this is a Rails server. We have a worker doing delayed job work, we have a worker doing rescue work, and we have here a clock process. So this is exactly how you can kind of describe your processes in a format that both Heroku and Foreman can understand. Those of you playing the home game will notice it looks a lot like YAML, but it's not. 3 dashes at the top of the file would make it YAML, but the idea behind this is that it's not just a Ruby file. It's cross-platform, and it works with, I mean, I use Foreman to start test closure add-ons, test Sinatra add-ons, Ruby, Rails apps rather, so it's cross-platform in that sense. So this gem Foreman is what I've been talking about, and really it's a process manager for local development. You're not going to use Foreman to run processes in production should you choose, but it allows you to describe your processes and then kind of see what you would get in production. So here's an example of installing Foreman and actually running some processes. This is running, the nice thing about Foreman is that you can tell it how many workers you'd like. Yeah, I guess we can do that. So this is an example of just calling Foreman. You can basically call it with Foreman start, but I wanted to show that you can tell it how many of each type of processes you want. Locally, it's going to start 1 of each, and you may or may not want to test that. Or, you know, see what happens if you have 2 workers, or you might have a process that you don't want to run, at least for a run. So here's what the output of Foreman looks like. Now, the beauty of embracing the Unix process model here is that standard out and standard error can now be all funneled into one location, and that's the kind of output you get with Foreman. So what I'm going to do now is I'm actually going to just do an example of live proc file, an example of using Foreman. So why not use a real app? So I'm going to go ahead. Can everyone see this, by the way? I can make this bigger. So here's a proc file. This is the proc file we use the Add-ons app. Let me clear and show that again. So what we saw, we have a web process. We're using Thin, a delayed job process, a rescue process, a scheduler, and then Redis. So what I'm taking advantage of here with the Redis process is that Heroku isn't going to, it's going to, when you push and you don't tell it what to scale, which we'll get to in a slide, you're going to get one web process and none of the others. So it's kind of not a problem for me to have Redis in my proc file. It allows me to just do foreman start, bundle exec foreman start. And there we go. And just to reiterate, that was foreman starting up. This is a standard Rails directory structure, no surprises there. So I'm just giving my web process a little bit time to boot up. People have, jokes about the JVM being slow, but starting everything is slow. So anyways, starting foreman, I can now actually connect to my local server. Okay, so this is my local version of the Add-ons app. I don't have my S3 credentials set up, so not all the logos are showing up, which is fine, so this is great. So now let's see some of the processes that are running in the background. So now I'm shutting foreman down. Oh, all right, I was gonna start it with, I was gonna show the rescue panel with one worker and then go to two, but let's just jump ahead of ourselves and start up two workers. So worker was not the name of the process, it's rescue. So as you can see, there were two rescue processes started, and then I'm going to go over here. Come on, server. Finn likes it when you sing to it. There it is. Alright, so I'm going to clear out some of these fail jobs. So there we go, we got 0 of 2 workers working, so foreman started 2 workers, they connected to the Redis that foreman also started, and now this front-end web process that foreman started is allowing me to administrate them. And then to further show the point, I'm just going to go ahead and queue up some jobs. So if you remember, my S3 credentials are not in the local version of the app. What did I do here? Rails runner. I wonder how many seconds of my life have been spent waiting for Rails to start up. I want that gem. Alright, there we go. And the work is coming through. These are all going to fail because, like I said, I don't have my S3 credentials, but this isn't a talk on uploading stuff to S3, so we're just going to call that fine. So there we go. Foreman making my local development very easy and a centralized way to kind of start my application. And then now that I've actually set everything up with Foreman and I've got it running, deploy is a matter of git push Heroku master. So to talk just a little bit more about this, at Heroku you use git to deploy. What is your master branch is what we serve as your site, and we detect what language it is, some language specific stuff, as Terence will get into. The second command is just kind of re-emphasizing this fact that you can push any branch to master, and this is how I do a lot of my staging pushes. I have a command branch name that just returns to me the name of the branch I'm on, and that lets me push to master. So we talked about having web processes and then how to scale them. So we saw in Foreman, you just do start with worker equals 2 or rescue equals 2, and it'll spin up 2 of those processes. Scaling them with Heroku is a matter of using the Heroku gem, doing Heroku scale web equals 2, or whatever you want those processes to be that you declared in your proc file, and that's basically it. You wind up with a bunch of managed processes that are exactly how you described, and our goal. So I'm going to just show Heroku scale. We'll do web equals 10 on our staging app. And through the magic of the cloud, I am now running 10 web processes. If I could spell Heroku, I could show you that. But since I cannot, nor I cannot type, I cannot show you that. Also the PS command, this would look a little bit better. So the PS command lists the processes that are running, and there we go, I've got 10 web front ends on my staging app. And that was it for Unix, and yeah. And then we can scale it down. Heroku Web 1. That's it. Cool. So we've seen Unix process model and how we use that in Cedar to make deploying different types of applications really easily. And now the Rails 3.1 specific stuff. Oh, that's right. I'm still gonna. Well, why don't we go ahead and take the mic? Because I'm still gonna be working the computer. Yeah. Oh yeah. I'll just jump.
Yeah. All right, so I'm here to talk about the through-on asset pipeline, how you deploy it on Heroku. So if you're not familiar, just to bring everyone up to speed, the Rails through-on asset pipeline introduced assets as a first-class system into Rails. So you have like an app assets folder, a lib assets folder, a vendor assets folder, and they work very similar to what you would put normal code in there for. So in app, you put application-specific code, so you put your application-specific assets like JavaScript views and stuff like that. And inside lib, it should be code that you wrote, but is not application-specific. And then vendor would be third-party stuff like jQuery and things like that. And so the asset pipeline handles specific things with JavaScript, so you can do things like CopyScript now, built in right into Rails 3.1, and you can also minify CopyScript, so it's the first time you don't have to sort of do that on your own. Rails sort of just handles that with just config options and certain gems, so you can use uglifier, a UE compressor for JavaScript, and it's similar with CSS. You have UE compressor to compress your CSS files, and then you also have built-in Sass support, which is really nice. And the other thing is, like, you can have other things besides just JavaScript and style sheets. So you can have fonts and images, is what I've seen in other apps as well. And you sort of just drop them into your app assets folder and have just folders corresponding to those things. So how do we get these things up on Heroku? There's 3 options to pushing them up on Heroku. So you can compile them locally and sort of handle that process on your local dev machine. You can have Heroku perform the compilation during slug compile, or you can have it done during runtime. And so I'll walk through each one by one. So when you're compiling it locally, Rails provides a rake task called assets precompile. And what this does, it runs off and uses sprockets to go through and convert your coffee script to JavaScript, go through, do the transformations for your CSS and what have you. And you want to make sure that you run it in the environment that you're deploying to. So for most people, this is production, but like if you're deploying to a staging app, you'd want your Rails environment to be staging. And this is important because it generates these MD5 sums, and they're dependent on the environment. So when you're actually running it, you want the MD5 sums to match, or Rails won't be able to find them. So it generates all this stuff inside this public assets folder, and it also generates a manifest.yaml file inside of this folder by default. And inside this file, it contains all the assets and the corresponding MD5 sum that works with it. So you want to make sure that you pass in the -f flag, because by default, Rails 3.1 will add public assets to git ignore, so Git will complain, and then just commit the assets. And then after that, you can just push to Heroku, and on the Git output, you'll see that we detect it is an asset. You're using the Rails 3.1 asset pipeline, and then you should see some message about detecting the manifest YAML. And so what this tells us is that you want to manage your assets, and Heroku will not do anything special with regards to running a rate task or anything along those lines. So it will treat it like any other Rails app. So what this gives you, it gives you complete control over the whole asset pipeline. You handle your own cache busting, like what assets are pushed up, and the whole life cycle for it. One of the nice things beyond Heroku is just that if you decide to compile stuff locally and push it up to some server like DreamHost or some shared hosting solution, you don't actually need a JavaScript interpreter on the box itself. So you can just compile locally, bundle that stuff in, and deploy. And then for Heroku, all the assets are bundled into the slug during slug compilation. So when the dynos actually boot up, the assets are ready and available and are good to be served. But there's some caveats for using this. The developer experience is horrendous. You are managing your assets using Git, so that means every time you update your assets, you have to make sure to remove public assets and then re-add them after you run the rate task, and it's just generally not a very good experience. And then it also leads to a bloated Git repo, because now you're adding binary files. So like you might have gzipped JavaScript files in there, and then over time, as you keep updating them, like you're going to slowly blow up like the size of your Git repo, and your Git commands become very slow. So the next option is to have Heroku compile the assets for you. And so all you have to do for this is just git push Heroku master. And then you'll see us detecting that you're using the asset pipeline again, and you'll see that now we will run the rate task. And you have to make sure that the manifest.yaml file is not there, because if it is, then we're assuming you're managing the assets. So the rate task will run, and the nice thing about this is it has all the similar characteristics of compiling locally, but this time you don't have to manage the assets yourself. So like you don't have to do any of that terrible like Git managing your assets. You can just rely on Heroku to cleanly build them each time you push up, and so the assets will always be like what you expect them to be. But there's some serious caveats with this solution. One of the things on Cedar is that we don't pass the runtime build environment variables to our build machines. So we don't have like, if you're using a specific version, like a specific Rails environment, or like what database URL you're using, or any of the resources. And this is a problem because assets precompile actually depends on assets environment in Rails 3.1, or in Rails 3.1.0, it actually depends on the rate task environment. And if you're not familiar, rate environment essentially boots up a whole Rails app when you run that task. And so if you have anything in your Rails boot up process that depends on an external resource, like say you have a production Mongo box, and Mongoid will try to externally connect to that during the boot process, and if it can't, it will raise an exception and blow up. And so rake environment will fail, and therefore assets precompile will not run. One of the nice things about Rails 3.1, we've been working closely with Jose Valim added this assets environment rate task, which which skips all the initializers. So anything in config initializers does not get run, as well as all the rail ties for all the gems do not get run unless they specifically opt in. So gems like compass rails that need to do stuff during the precompile task will be able to plug into this process and make sure the assets config options are specified so you can compile those things. And then finally, we have compiling during runtime. So the deployment process is fairly similar. You just push the Heroku, and you'll see we detect that you're using the asset pipeline. We try to run the rate task, but the rate task will abort for some reason or other because of some build time thing. And we will detect that it is aborted, and we will inject this plugin that I wrote, which basically just enables asset compilation during production. It flips a configuration option in production mode and sets it to true. And when we post slides later, you can click this link and look at it. It's fairly simple. So one of the caveats with this is that since we're building on the assets during runtime, we need to have Node or some JavaScript interpreter available to actually compile this stuff using CoffeeScript or Uglifier. And this can be a pain in the butt if you don't have that available in production. You have to like clear it with your ops team to get this stuff installed. And then also like the assets are compiled on the first request. So after the dyno boots and you make your first request to Rails, after that it actually compiles the assets. So this is a problem because on Cedar you have a 60-second window to give a response back. And so you imagine like you just did a new deploy. And now you have to wait for the dyno to boot, for Rails to boot up, and then when you hit that first request, you have to wait for the assets to compile, and then you have to wait for the request to actually be served. And if all this takes greater than 60 seconds, it will time out. And so you can imagine, say I have like 20 dynos, I have to do this 20 times, once for each dyno. And so the first request for all these will time out, and that's obviously not ideal. We found that most of the people that have been using it have not run into this problem, but it's obviously app dependent. And then Chris is gonna do the demo of the stuff that I take the link.
Yeah, sure. So just because it's my machine, so I figured it'd be easier. Alright, so what am I doing here, Terence?
So let's show just compiling stuff locally, right? So you need to check out that compile branch. Okay. And you probably will just want to do a new branch so we don't check that stuff into this one. So we're just checking, so we have a pre-made branch of just a Rails 3.1 app that works, and we're starting a new branch so not to mess up the other demos. And so here we're running the rate task. You need to compile locally, though. So we'll run Rails m equals production bundle exec rake assets precompile, and this will let Sprockets do its thing, compile the assets, convert all the JavaScript and the CSS. Bundle install.
Notice how using the pre-release version of Bundler, how quick the fetching the dependencies went. I mean, these are lots of gems here, but Rails is built on it. Anyways,
let's run that rake task.
All right.
Again, we're waiting for Rails to boot. So we should have a public assets folder. If you ls, yeah. And so if you want, just cat the manifest.yaml file in there.
So the git ignore has public assets? Then?
Yep. So yeah, it's in public assets. So you'll see it has all the assets and as well as the MD5 sums. And we need to add the public folder before we push.
You have to use -F because it's going to get ignored. There we go. Have like some elevator music.
Yeah.
Oh, so it's gonna run this one first.
Yeah. So here you can see it detecting the manifest YAML, assuming the assets were compiled locally. And once the dyno launches, we can hit the page and see that it has that Rails image that's in this repo. It's up there, bro. Oh, it's in the terminal, right? Just click the URL in the terminal.
There it is.
There it is. Has the
That's the asset.
So let's check out the compile branch again. And then
right.
we just need to git push Heroku master to show it running the rate task.
And I have to force because it's not just adding to the current branch. Free is pretty fast. Of course, he's rolling it, but.
What?
Is the bundler 3 already on?
Yeah, bundler, the Cedar stack runs 11.rc.
So there was.
Yeah, so this is it failing, and so rate got aborted, and you see we inject the plugin, and if we go to the URL, it will still show the image.
So this was the case where compile failed.
So if you go back to the, all right, so we still have it, git log. Wait, git status. Did you push master, bro? When you get pushed, push master.
Why didn't push?
Branch. So we'll try this again to show it successfully running the rate task and that the assets are still going to be there.
So I pushed the master branch up instead of the compile branch up. So that was an example of, we did the examples a little out of order. Do I have to force it? Right, so that was an example of compile failing.
Yeah, so that was, the previous example was it running, compiling during runtime.
So here I'm refreshing and now it's fast after it's compiled once.
So you can see the rate task completes successfully. We don't inject that runtime compile plugin, And if we go to the URL, we see that the PNG is still there. Yep. So I just want to make a final note on JavaScript interpreters. So Rails 3.1 uses a gem called exec.js to detect which JavaScript interpreter you're using. So this is nice for people. So like on OS X you have Apple JavaScript Core, and in Windows you have Microsoft JScript, and you can use things like Mozilla's Rhino. If you actually go to the exec.js README, it'll show all the ones that are supported. But the two options you really have on Heroku are the Ruby Racer and Node.js. And basically, I'm saying don't use the Ruby Racer. It consumes lots of memory. I have fielded a lot of Rails 3.1 tickets where they've used this, and the solution is always removing the Ruby Racer, and then their app works perfectly fine after that. We installed Node.js on every single Cedar app where we detect exec.js, the gem, so feel free to use that. It is there. It is much more memory efficient. Do not use the Ruby Racer.
So some quick stuff. We did want to show Linux deploys with form and export. So form and export allows you to actually take those managed processes and then export them in a format for Unix, so you can have an upstart format and then just start those processes like so, or you can use the init tab format. So that was just a quick, if you want to use forming but still deploy to Linux.
So we've been working with the Rumble Lab guys on getting your assets to sync with S3 and CloudFront and other things. So they have this gem called Asset Sync that will hook into the assets precompile process on Heroku and will essentially just upload them to an S3 bucket where you specify the credentials and the bucket name. Obviously, with the concern that build vars are still not being passed to the compile process, you'd have to hardcode them. But they also have instructions if you don't want to do that, you're not comfortable putting that in the code to run it after it's been deployed. And we're still working on trying to get this process to be better and cleaner. But if you want to use a CDN and not have it being served off the dyno, this is definitely a pretty good solution, and we have a Dev Center link as well that will walk you through the whole process step by step. So, any questions?
So did you say the node is already there? You don't have to do anything special?
Yeah. So anytime we detect the exec.js gem inside your gemfile.lock, essentially, we will automatically vendor that in. So if you have any Heroku app, you could literally just have a gem file that says gem exec.js and do a bundle install, push it up to Heroku, do Heroku run bash to get a console, and then if you look inside your bin directory, you'll see it there.
You mentioned on the doing the precompile or doing the asset processing during the precompile state. That saves that developer experience. What about like wrapping your git push command some bash script that does all the stuff that you would need to do, like especially syncing up S3s, so that when you do a deploy, sync your assets. Do people do that, or is that?
Some people have been looking into it. Like Dr. Nick actually has a post about you can have a pre-commit hook, and so it's essentially just a bash file that's executable, right? And so in your pre-commit hook, you could have something that works with Asset Sync that pushes the assets up. And the nice thing there is that since all the assets use MD5 sums, right? Like when your new app goes live, you don't actually have to take down the old assets, right? So the moment that the dynos flip over, your assets are already there, and all the URLs have the hash in there, and it will use that instead. So that's actually pretty good.
Cool. All right,
Cool.
thanks.
Thanks.